Right, so we've got a rectangle and it has a certain restriction on its area. And this is going to end up being nothing but a quadratic inequality, which we'll solve. But the important thing is that there's a physical restraint on the length of the sides. And we'll find that when we solve the quadratic inequality, we get a potential range of values for x, but some of them aren't allowed by the physical world. So if you look, for instance, that the width of this rectangle is 2x minus 4, if we have an x that is less than or equal to 2, then that side is negative, and that doesn't make sense in the physical world, and we'll see that happening. So let's get on with it. We're talking about the area A, and we know that it is less than 3x plus 27, and we know how to work out the area. We're just going to find the product of the sides. So we can say that 2x minus 4 times 3x plus 2 is less than 3x plus 27. And I'm just going to simplify this and then solve the inequality. I don't think it's a bad idea actually to start with the equals. Start by changing this sign here, this angle bracket, to an equals sign, because we're not really going to talk about whether or not we want greater than or less than until we've solved the quadratic. And setting that angle bracket there, that less than sign to an equals sign early on, means that we don't have to worry about flipping the less than to a greater than if, for instance, we divide or multiply by a negative number, which is what you normally have to do. So I think it's a good idea whenever you're doing a quadratic inequality, or indeed any sort of inequality like this, is to start off by setting the less than sign to an equal sign, and then thinking about putting it back at the end. So let's get on with this. I'm going to multiply out this bracket. So 2x times 3x is 6x squared. So 6x squared, and then plus 4x minus 12x minus 8 equals 3x plus 27. And I'm going to gather everything on the left hand side and have a 0 on the right hand side. So I've still got 6x squared here. I'm going to end up with minus 8x because I've got 4x minus 12x, but then I'm going to take away another 3x, so I'm going to end up with minus 11x. And then I've got minus 8, but I want to take away 27 as well, so I've got minus 35 on this side, and I've got that equal to 0. You can put this in the quadratic formula. If you like, use your calculator. The only thing, as usual, you must do is show the substitution into the quadratic formula. I'm going to split the middle term, which is what I normally do. So I've got 6 times minus 35 is minus 210. So I want to multiply to that and add to minus 11, and that's minus 21 and 10. So 6x squared minus 21x plus 10x minus 35 is 0. So I've still got minus 11x in the middle, but I've split the middle term. Now I factorise separately, so I can take out, I think I can only take out an x there, can I? And wait, no, I can take a 3. So 3x, that gives me then 2x minus 7. And then when I take the factor of 5, which is the greatest I can, I should also have 2x minus 7, and I do, equals 0, which gives me 3x plus 5 times 2x minus 7 equals 0. And my quadratic therefore says, if I just envisage 3x plus 5 equals 0 or 2x minus 7 equals 0, that gives me x equals minus 5 over 3, or x equals 7 over 2. And since I wanted, I had a less than sign, then having simplified this and set everything to 0 here, I'm looking for the areas where I'm less than 0. But we'll come to that in a second, because in fact this range here doesn't work. According to the sides, if I say for 2x minus 4 to be greater than 0, and it must be greater than 0, it can't be 0, this side length here, because then we won't have any sort of rectangle at all, then we must say x is greater than 2. And similarly here, for 3x plus 2 greater than 0, then it must be true that x is greater than minus 2/3. So looking at this, what does the physical world say? I can label these, if you like, physical constraints. I need to choose the one of these, x greater than 2 or x greater than minus 2/3, which also satisfies the other one. So x greater than minus 2/3 does not satisfy x greater than 2, but x is greater than 2 does satisfy x is greater than minus 2/3. So I need the one that is the most restrictive, that satisfies both. So we have to say here, so x is greater than 2. This is a physical restraint. Now my quadratic here says that x can go anywhere from minus 5/3 up to 7 over 2, which is 3.5. But the world says that x has got to be greater than 2. So what I've got here is I've got this sort of number line. Let's just have a quick look at, bearing in mind the shape of this quadratic here, the shape of this quadratic, we've got a positive coefficient of x squared. So we know it's U-shaped. And we are looking for, this is y equals 0 there, we're looking for the points at which the curve is less than 0. So it's less than 0 at these points here, okay? Any of these x values in the middle give us a y value that's less than 0. So we're looking for, we've essentially got a number line, which is, here's our number line. We've got minus 5/3 there, and all the way up through 0 to 7 over 2 here. But this extra constraint is coming into play. So this value here of 2 is in fact the minimum that x can be, according to the sense that tells us that the length of a rectangle can't be negative. So in fact all of this stuff isn't relevant, and I don't want that. So that tells me that x has to be greater than 2 and less than 7 over 2. Is it less than or equal to? No, it isn't, because it said less than at this point. So I've had to think about the quadratic. If you know, I'd had a negative coefficient of x squared, then my quadratic would have been this shape. And the points less than 0, in fact, would have been outside, and I would have had to talk about an inequality out there instead, but that's not the case. So I need to say that the final inequality is 2 is less than x is less than 7 over 2, and that's the range of possible values for x. So what's happened here is I've solved my quadratic inequality as I normally would, but then I've quickly had to check these physical constraints here that are given to me by the fact that this is a real world problem involving a rectangle, and that's added yet another constraint on x, that it's greater than 2. So this whole range that I got from my quadratic actually gets limited by the this extra constraint, and that's what gives me my final answer there.